Hi, welcome to our next level 3 trigonometry video. This is our second video on general solution. Now to remember, we have three general solutions based on the sine, the cosine and the tan functions. And for each general solution we have two versions. One is set up in radians and one is set up in degrees. Alright, here's our first example for this video. Find the general solution for the trig equation 2 sine x minus 1 is equal to 0.4. Now notice in this trig function we have an amplitude change, the 2 out the front of the sine x, and we also have a vertical shift, which is the subtract 1. Right, here are the two versions for the sine general solution, one in radians and one in degrees. And for this first example, we're going to focus on the radians once again. So x is equal to pi times n plus negative 1 to the power of n times this number alpha. Right, well we have to do some rearranging to get alpha. So this is what we're going to have to do. We're going to have to take the minus 1 and put it onto the other side and add 1. So we get 2 sine x is equal to 1.4. And then divide both sides by 2 to remove the amplitude to get sine of x is equal to 0.7. Now we've got it in the form of sine x equal to a number. Once we've got it into that form, we can take the inverse sine of 0.7 and get our value for alpha. Just make sure your calculator's in radians because we're using the radian general solution formula. So we get 0.7754, and this is the value we're going to use for alpha. So we can write down our general solution, x is equal to pi times n plus negative 1 to the power of n times 0.7754. And that's it. There's our general solution for this trigonometric equation. Now once again, we can substitute in different values for n. We could start wherever we wanted, but I've started at negative 2 and gone through to positive 3. We could keep going, positive 4, positive 5, positive 100 and so on, and we can find any solution that we require. Now, the key difference between this example and the one in our last video is we had to do a little bit of manipulation to get it into the form of sine of something. Sine of x is equal to a number. And we had to do that before we moved on and took the inverse sine to get alpha. All right. Here is example 2. Find the general solution for the trigonometric equation sine bracket 3x is equal to 0.75. This time we have a value of bx, and this represents the period change. We'll deal with that at the end. I'll show you how to deal with that. For now, here are the two versions for the sine general solution, one in radians and one in degrees, and again I'm focusing on radians. So x is equal to pi times n plus negative 1 to the power of n times this number alpha. Now because we have sine of something equal to a number, we can straight away work out the inverse sine of 0.75 to get alpha. Don't worry about the 3x in the brackets. We have sine of something in the brackets, 3x, and once we get sine of something, we can take the inverse sine to work out what is 3x. Now this is the value we're going to use for alpha. We're going to use 0.8481 for alpha. So we're going to write down x is equal to pi times n plus negative 1 to the power of n times 0.8481. Once again, I've rounded to four significant figures. However, we do have this 3 in the bracket, 3 times x. So what we have to do is divide everything by 3 to get our general solution and undo the period change. Everything has to be divided by 3. So what we're going to do now is split this up. We're going to go pi n divided by 3 plus negative 1 to the power of n times 0.8481 divided by 3. Now we can simplify this down to get pi n over 3 plus negative 1 to the power of n times 0.2827, because 0.8481 divided by 3 is 0.2827. And this is the simplified version of our general solution. We could substitute in different values of n to work out our solutions. Thanks for watching.